Hello, friends. Thought I'd make a little video today about some of the M6 Newton questions. We did do some work similar in class, but sometimes it's nice to have a little extra support video. So here we go. I'm sharing my screen, I think. Yep. So this is an example of the kind of question you get. And again, the challenge here is that we know that there's 9s and 10s and 11s and 12s and 13s and 14s and 15s. We don't have the raw data. If we had the raw data, we could just say to Excel, hey, give me the mean. First thing I'm going to do is get this into Excel, because Excel is my tool. Excel guy, paste. I'm going to zoom in a little bit. Okay. So what we did in class was we recognized that what this really means is I've got 9 8 times. If I counted that right, this is 8 times. And when I do the mean, I'm adding those up. So I could do the sum of all those 9s. And this would be a very long way to do it. And just write out what this table means back in terms of the raw data. So we're going from organized to raw, which should seem a little weird. But notice that 8 9s is also just 8 times 9. That's what's happening here. And so this leads to a more direct way to solve the problem that doesn't involve writing out all the data, which is to find what I like to call the contributions to the mean. I often shorten that up and just say contributions. And then, of course, I can just autofill because I've set up a formula there. I need to add all of those up because I have the contributions from the 9s and then the 10s and 11s. And then this total is the sum of everything is 220, but I need to divide at the end by how many there are. And that's contained in the table as well, because if I look at the sum of the frequency table, that gives me how many I have. So there's 20 of those. So I do 220 divided by 20. And I've got 11. And I'm going to pop that in and see if I get positive feedback. Again, one of the points of these Newton assignments is to really kind of give you a chance to practice the concepts outside of the workbook, just to make sure that you're strengthening your understanding, because it is possible to kind of go through the workbooks and follow the prompts and just kind of, I do what you told me to do, but I'm not really thinking about it. So really trying to check in with you, make sure you're thinking about it, make sure it makes sense to you. Let's take a look at another question. Well, actually, let's switch objectives. Find, it doesn't let me go forward here, but I could go into standard deviation. Okay, which of the data sets represented by the following histograms has the smallest standard deviation? The concept that we're working on here is that standard deviation is a measure of spread. So I want to know which one of these is the most spread out. This looks pretty concentrated to me. It's between 60 and 90. Again, I might think of in terms of range, which is a very easy thing to calculate. If this was from 60 to 90, the range is 30. Let's go look at some of these other ones. This is definitely more spread out because it goes from 40 to 100. This goes, wow, all the way down to almost a 0 to 120, more spread out even. And then back to, yeah, so definitely picking this one because this is the most spread out. I'm not thinking about standard deviation as a calculation. That would be an insane thing to try to accomplish given what I'm provided. So I'm really conceptually thinking about spread. How much variation is there? Oh my gosh. Oh, because I got into thinking about spread and then I wanted the most spread. Okay, well, I reread the question and in fact, we don't want the biggest spread, we want the smallest spread. Okay, and then it's providing me an explanation. And again, this is part of what is supposed to be helpful in this online space is, you do the question, if you get it wrong, I think you get 2 times. Then you get to, circle back and try it again. So the range rule of thumb, and I think they do the range divided by 4, but really, I don't need to do a special calculation. If I just find the range, that is a measure of spread. And so if it has a larger range, it ought to have a larger standard deviation. I think that's the point of the question here. So I'm kind of looking at the ranges. I got to do some sorting in my head because these aren't sorted, which is not very nice of Newton, but that's fine. It kind of gets at the point of like the biggest and smallest. Okay, 102, 54. So this is like 50, 48. This is a lot. But again, I'm not looking for a lot. I'm looking for the least. Oh, this is really, no, 100 to 70. That's 30. Okay. Looks like 50 is the smallest. Looks like 72 might be the biggest. That's even smaller. Okay. 102, 36. Oh, wait, this is way too big. I don't even need to calculate it. This is the smallest one. Range and standard deviation are measures of spread. So I can use that as a stand-in to give me a concept of the smallest amount of variation. I'm picking sample 3. All right. Okay. I'm going to stop there because I like to keep these relatively short, but send me a request. Remember, if you're stuck on a question, if the Newton explanation isn't working for you, you're welcome to send me a video and I'll give you my thoughts on it. All right. Hope you're doing well.